children. Children, today we are going to learn types of functions. But before starting with this topic, I would like to recall the definitions of relations and functions. Children, your relation is a collection of subset of Cartesian product from A to B. Let's suppose your relation is defined as 1, 2, 3, 4, 5, 6. So this is your given relation. Now the numbers which are written at the first position are your domain. So domain here is 1, 3, 5. And the numbers which are written at the second position are your range. So here range is 2, 4, 6. Now children, given relation is said to be a function if its domain, every domain has a unique image. That means here I can see also that 1 has its image as 2, 3 has its image as 4, 5 has its image as 6. So all of them are having different and unique image. That's why this given relation is also a function. Let's suppose another example, say this is 1, 2 and again it is 1, 3 and say it is 4, 5. So here you can see your domain is 1 and 4, but here you can see this 1 is having its image as 2 and 1 is having its image also as 3. That means here this domain is not satisfying the uniqueness. So here this given relation is not a function, or in other words I can say all the functions can be relation, but every relation is not a function. So this, keep it in mind that if it is a function, its domain should not repeat. Moreover, we can simply remember it like this: same number cannot come at first position. So this is a relation, but this is not a function. So every function can be a relation, but every relation cannot be a function. Now let's come to types of functions. First of all, we'll discuss constant function. Now children, the name is only suggesting you that you should have a constant value. Now your function can be represented with fx or y. That means your function is expressed in terms of x. So your constant function, when you want to define a constant function, then it will be written as y equal to constant function, or simply I can say fx equal to some constant value. Constant value can be positive as well as negative. So here I can say, let's suppose y equal to 5, and if I want to show it graphically, then simply say this is your 5, so it will be parallel to y-axis. So this is the graph of a constant function. Now children, what you can say about domain? So domain is what? Domain are the elements of set A. Set A here it is x, because we always write the Cartesian product in x, y form, which is ordered pair. That means this is your domain and y is your range. So what you can say about the value of x? Here x can take any value. It can be 5, it can be -1, it can be -20, it can be -100, +100, anything. So domain can be any real number. But what about range? Range will be only that constant value which is given in your function. So here range is -1 if it is defined, if your function is defined as y equal to -1. So range will have that constant value which is given in the function, whereas domain can take any real value. Second, identity element. Identity function. Now children, the name itself is suggesting you. Identity means identical. If your domain is equal to range, then it is your identity function. And the function can be represented as y or fx equal to x. Function is equal to x. That means range is equal to domain. So what you can say about your domain? Domain can take Domain can take any value, any real value. So domain can be real. That means x can take value. If x is 1, then y is again 1. If x is minus 1, then y will be again minus 1. If x is 0, then y will be 0. That means domain can take any real number. What about range? Range can also take any real number because it is 1, minus 1, 0 and so on. Graphically, if you want to represent it, then if say x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. If x is 0, y is 0. If x is minus 1, then it is again minus 1. So you will be getting a straight line passing through the origin. Let's come to the next function. Next is your polynomial function. Polynomial function. Children, polynomial function, its general form can be written as y equal to say a0 plus a1x plus a2x square plus a3x cube and so on. And you have read in your lower classes that polynomial can be linear polynomial, it can be a quadratic polynomial, it can be a cubic polynomial and so on. And you know that linear polynomial can be written as ax plus b in its standard form. It can be written as ax square plus bx plus c in standard form. And cubic, it can be written as bx square plus cx plus d. So if I talk about graphical representations of these polynomials, then in linear polynomial we always get a straight line in any way. In your quadratic polynomial, you will be getting a parabolic form, either this way or this way. So you will get intersection on x-axis at 2 points. Your cubic polynomial will be again a graph which will cut your x-axis at 3 points. So different ways are there to represent polynomial. This polynomial, graph of the polynomial will depend on the value of x, that what value of x you are taking. So what we can say about domain here? Domain here, that means you can take any value of x. That means domain can take any real value. What about range? Now if your domain is your real number, then again your range will be any real number which will depend on the value of x. So range will again be your any real number. Now let's take the fourth one, which is your rational function. Children, you have read in lower classes that rational numbers can be represented in p by q form, where q should not be equal to 0. But since we are reading it under the topic functions, we will be writing it as px by qx, where qx should not be equal to 0. Px and qx are polynomial. So say for example, I can say this is x minus 2 upon x square minus 4. Say if this is your given question, rational functions, this is your rational function which is in px by qx form. So here it is the condition, qx should not be equal to 0. So for what value of x this is coming out to be 0? So for x equal to 2 it is coming out to be 0. But we should always avoid the denominator getting as 0. So here I should not be taking x equal to 2, because on putting x equal to 2 you are getting denominator as 0. So here it should be defined that x should not be the value of 2. So what we can say about domain? Domain, that means domain I can have any value of x except this. Or I can say domain should be defined in x. That means x should be defined by that value. Here x is not defined. 1 by 0 is infinity, which is not defined. So if I am taking x equal to x equal to 2, it is not defined. That's why I will not take x equal to 2. So domain should be defined in x. Let's see the fifth function. Next is absolute value function, which can be defined as y equal to x. Children, you are aware of these standing lines because you have read in lower classes that if any number is there in between these two vertical lines, then you will always get a positive value. If it is -5, then you will get a positive value. But in class 11th, you will be remembering or learning it like this. If it is mod of x, then we have to define it for two things. One for x is greater than 0 and another for x is less than 0. That means y will be positive, that means y can take the value positive x when x is greater or equal to 0, and y is negative, y can take the value negative if your x is less or equal to 0. So here the function is defined in two ways. When it is positive, so for this value it is positive, and for x is less than equal to 0, this is negative. So here I have got two functions, y equal to x and y equal to minus x. That means if I put here x as 1, then my y will be 1. If I put x as 2, then my y will be 2. If I, and so on. If I put my x as 1, my x as 1 over here, that means I'll be taking it as, say if I am taking it as -1, because here it is x is less or equal to 0, that means I have to consider the values which are less than 0. So if x is your -1, then it will give you 1. If x is your -2, then x will be 2, and so on. So if we see it graphically, if we draw the graph of y equal to x and y equal to -x, then if it is 1, it will be 1. If it is 2, it will be 2. So you will get a straight line over here. For next you see, if it is -1, then it will be 1. For -1, it will be your 1. So -1 and 1, that means you will be getting the value here. This will be say your -1 and 1. Again this will be say your -2 and 2. So you will get a graph in V shape. What you can say about domain and range? Here you can see domain can take any real number. Here it can be 1, it can be -1, -2, any real number. But for range, you see here, you are getting range as your positive values. So range will be non-negative integers. Non-negative, either you can say non-negative integers or real value. So non-negative integers. Now let's define the sixth function, which is the greatest integer function, which is also known as step function and also known as floor function. Children, in your NCERT, you will be dealing with this word only, but if you will check other authors' book, then you can get this word step function, and another word for it is a floor function. Now children, whenever we are talking about greatest integer function, then we should always be writing the function in big bracket. So the function can be defined here as y equal to x, or I can simply write it as y floor. This is your floor. This is your floor. Y equal to x. This is either you can write in this way or you can write in this way. Now children, whenever you are talking about greatest integer function, let me explain you this with an example. Say if y is equal to 9.99, say if it is y equal to 9.03, say y equal to 9.54. Now children, this bracket itself, when we are talking about functions, this bracket itself means greatest integer function. So here in day-to-day life, we take 9.99 approximately equal to 10. We take 9.03 approximately equal to 9. We take this approximately 9 because this is more than 5, and then the next number is more than 5. That's why we can say it approximately equal to 10. But whenever we are talking about greatest integer function, these values should not be considered here, but instead you see, if say this man has 9.99 height and this man has say 9.03 height and this has 9.54 height, but for all of these three persons the floor is the same, and say it is of 9, they are standing on the 9th floor. Okay, So that means whatever is written here will be considered the value. So the greatest integer function for 9.99 will be 9. For 9.03 again it will be 9. For 9.54 again it will be 9. So the floor is to be taken into consideration and not the values which are written after the decimal. This is only for positive values. For positive values I am talking about. For negative we have a different rule. Now if we want to draw the graph, then x, say if I am having x 9.99, then also I am getting it as y equal to 9. That means I will get a graph at y equal to 9. So it will be just a straight line. Now we'll talk about next function, which is your Signum function. Children, okay, here what is your domain? What you can say about domain? So domain can have any real value, so it can have any real value. For range what you can say? It will have a positive integer. So again I can say, for I am just talking about positive values, so it will be a positive integer. Okay. Now for Signum function, children, domain can have any real value, but we have restriction on range. Range should always lie between 1, 0 and 1. 1 when we take x greater than 0, 0 when x equal to 0, and minus 1 when x is less than 1. So when x is less than 0. So this is the restriction over range, that whatever domain you are taking, that should have range as -1, 0 and 0. When x is greater than 0, that means for all the positive values it will be always 1. For x equal to 0 it will be 0. For all the negative values, maybe it is -1, -100, -40, whatever. If x is less than 0, then your range is -1. So Signum function can be defined as fx, or simply I can write y equal to mod of x upon x. So simply here I can say if x equal to 3, then what I will be getting? 3 by 3, which is equal to 1. If I take x equal to 4, then mod of 4 upon 4 will be equal to 1. That means whatever value your x takes, your range will always coming out to be 1 in the case when x is greater than 0. If I take x equal to -3, then it will be -3. Y will be equal to -3 by 3, which is equal to -1. If I am taking x equal to -4, then y will be equal to -4 by 4, which is equal to -1. So whatever negative value your domain is taking, your range will always coming out to be -1. So graphically you can say your Signum function is this is your x equal to 0, so this is your y equal to 1, and this is your y equal to -1. So your domain here will take any real number, but your range will take -1, 0 and 1. Have a look.